Hello everyone. In this video, we're going to be taking a look at the angle addition postulate. So much like the segment addition postulate that we talked about, that postulate allowed us to add segments together to find total lengths. The angle addition postulate is going to allow us to add or subtract angles together so we can find individual angle measures or we can find total angle measures. So let's start off by just taking a look at what the postulate says. It says if P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measures of angle RSP and angle PST. There's a lot of letters in there. There's a lot going on. So let's go back to the beginning. And this time we'll go step by step and we'll put a diagram with this as we go. So the very first piece of the sentence, it says P is in the interior of angle RST. So let's start with that angle RST. So we'll draw in our angle. This can look like anything. And then I need a couple points. Now based on the way this angle is named, because S is the middle letter, I know the vertex is the point S. And then my other 2 points, we have R and T. Okay. The second piece of that first part, it says P is in the interior of this angle. So somewhere on the inside, we have this other point P that's kind of hanging out. All right, so that's where we're at so far. Now the next part says, then the measure of angle RST, so that is the measure of the entire thing, is equal to the sum means addition, of the measures of these other two angles. When I look at these other two angles, they both include that other point P. So let's put in one more ray. So we have another ray that's going from S through P. Drawing that one in, now we have two separate angles here. So what this postulate is saying is that the entire angle, so the whole angle, the measure of angle RST, that entire measure is equal to the measure of RSP, so the measure of the smaller angle here, and then the sum, so plus the measure of our other angle. So in other words, if I take the two smaller angles and I add them together, I'm going to get the measure of the entire thing. A couple important notes here is these two angles, the two smaller ones that I'm looking at, they do share a side. So because they share that side of the ray SP, that allows me to add them together. Let's just put some numbers in here to help us out a little bit. So for example, let's say that this angle is 40 degrees. So maybe we measured it and we found it to be 40. And then this angle down here, maybe this one is 25 degrees. So this postulate says that if I take the 40 and I add that to the 25 degrees, that should give me my total. So then the entire angle is 65 degrees. So then the entire angle from here all the way to that far side, that's 65 degrees. So that's what the postulate says. Now we can also use this to write and solve equations. And let's take a look at an example where we do that. Okay, so here I'm given an angle measure. LKN is 145. Let's take a look at that in the picture right away. So L to K to N is 145. So the entire angle, so this entire span here, that crosses 145 degrees. I want to find the measure of angle LKM, so that's the one on the left, and the measure of angle MKN over here on the right. Okay, so now our angle addition postulate says if I take these two smaller ones and I add them together, that should give me the measure of the big angle, which in this case is the measure of angle LKN. So now we just have to do a little bit of substitution. So over here on the left, LKM is represented by the expression 2x plus 10. So I can substitute that in for this first part. Over here on the right, this angle is represented by 4x minus 3. So substituting that in, plus 4x minus 3, altogether, that should be equal to the entire angle, which we were given is 145. So the angle addition postulate allows us to set up this equation. And now we can solve for x. So the first step, let's combine some like terms on the left-hand side. So 2x and 4x, I end up with 6x. 10 minus 3, we have plus 7. And then this is still equal to 145. We're going to isolate my variable term, so I'm going to subtract 7 from both sides. We get 6x is equal to, let's see, that's going to be 138. And then lastly, let's divide both sides by 6 to find our value for x. So 138 divided by 6 is 23. Okay, but we're not quite done yet. I actually want to find the measure of these two angles. So the measure of angle LKM, I need to do a little back substitution to find that out. So now that I know x, I can substitute that in. So instead of the x, we'll do 2 times 23 plus 10. And if we simplify, 2 times 23 is 46. And if we add 10, we get 56 degrees. So over here on this side, this angle is 56 degrees. And I can do the same thing to find that other angle. So now the measure of angle MKN. Now again, instead of x, we'll plug in 23. So 4 times 23, and then we'll subtract 3. 4 times 23 is 92. And we'll subtract 3, so we get a total angle of 89 degrees. So then this angle over here on the right, this is 89.